Episode 8, Ribavirin and Mitochondrial Dysfunction, a double-edged sword. Welcome back to Ribavirin Reminiscence and Lingering Load in Long COVID-19. I'm your host Anushka, and today's episode dives into a topic that reaches the very heart of cellular life, the mitochondria. Imagine a car engine running smoothly on high quality fuel, but then the wrong type of fuel is pumped in. What happens? Over time, the engine's efficiency and performance begin to decline, and we start noticing road wear and tear. Could ribavirin, a decades long old antiviral, be inadvertently pouring the wrong fuel into the cellular engines of our body? Fatigue, that all encompassing energy draining symptom of long COVID, has some researchers wondering if the culprit might not just be the virus or the immune system, but perhaps the treatment itself. To help us unravel this mystery, I am joined by Saakshi, a microbiology graduate who's passionate about understanding the cellular mechanisms at play in viral infections and post-viral recovery. Welcome to the show, Saakshi.
Thanks for having me, Anushka. I'm really excited to dive into the world of mitochondria today. They are the unsung heroes of our cells and at times silent casualties of our therapies.
Let's begin at the molecular level, the foundation upon which everything else stands. How does ribavirin interact with human cells, especially beyond its antiviral effects?
Ribavirin is a guanosine analog. It mimics the natural nucleotides our cells use for RNA synthesis. This is what allows it to disrupt the process of viral replication. But the issue lies in the fact that our own cells, especially our mitochondria, also rely on these building blocks. Mitochondria are quite unique because they have their own small genome and replication machinery too. In studies with cell cultures and animal models, it's been observed that ribavirin can inhibit mitochondrial RNA polymerase. This leads to several problematic outcomes, such as impaired oxidative phosphorylation, reduced ATP production, which is the cell's energy currency, and also increased production of reactive oxygen species, or what we call as ROS, which causes oxidative stress.
So it's a bit like giving a high octane fuel to an engine designed to run on regular. It seems to fit, but ultimately it breaks things down in the process.
Exactly. Ribavirin can act as a false friend at the molecular level. It looks like it's helping, but it's actually creating long-term problems by disturbing the delicate balance within our cells.
Bringing this into the world of long COVID, fatigue is like one of the most common and debilitating symptoms. How does mitochondrial dysfunction fit into the puzzle?
There's growing evidence that mitochondrial dysfunction plays a central role in many cases of long COVID. Studies using muscle biopsies, metabolomics, and even PET imaging have shown impaired energy metabolism in cells, mitochondrial fragmentation, where the mitochondria become damaged and dysfunctional, and also increased lactate production even after minimal exertion, which is a hallmark of inefficient energy production. These findings are strikingly similar to what we see in other fatigue syndromes such as ME or CFS. And here's where ribavirin becomes a concern. In clinical trials or off-label use, if we are administering ribavirin to treat persistent viral symptoms, It might further strain mitochondria already under duress in long COVID patients.
Then, if I understand correctly, in a way, we are looking at a vicious cycle. The mitochondria are already struggling, and ribavirin could push them past their tipping point, exacerbating fatigue and other symptoms.
Exactly. It's like adding more weight to a backpack that's already too heavy. The cumulative stress could make things worse rather than better.
What does the evidence say? Has ribavirin been definitively linked to mitochondrial harm in humans?
In humans, the evidence remains mostly indirect. For example, patients treated with ribavirin for hepatitis C often reported some symptoms like persistent fatigue, muscle weakness, and mood disturbances. While some of these side effects were initially attributed to interferon, another antiviral often used alongside ribavirin, as we know, later studies suggested that ribavirin itself might contribute to mitochondrial toxicity. In vitro studies have shown that ribavirin can interfere with mitochondrial RNA synthesis and also disrupt membrane potential, which in turn directly impacts the cellular energy production. However, systemic studies in long COVID patients specifically are still lacking.
So, we are seeing the symptoms, which is the smoke. But we haven't pinpointed the exact fire yet.
Exactly. The evidence points in that direction, but without targeted studies on long COVID, we can't say for certain that ribavirin is the cause of mitochondrial dysfunction in these patients. But the plausibility is there, and it definitely warrants the further investigation.
Let's imagine for a moment that we confirm ribavirin does have moderate mitochondrial toxicity. What's the trade-off in using it to treat long COVID?
It really depends on the specific use case. If ribavirin is effectively suppressing persistent viral replication in a subset of long COVID patients, then the benefits might outweigh the risks, at least temporarily. However, if the dominant mechanism of long COVID is more metabolic or autoimmune rather than viral, then ribavirin could do more harm than good. It's all about precision, using the right treatment for the right patient and also at the right time. It's not just about throwing antivirals at the problem.
Well said. So, patient selection and timing are absolutely critical.
Absolutely. And even the dosage matters. Lower doses could potentially minimize toxicity while still exerting some antiviral effects. But it's all about balancing the scales very carefully.
If clinicians do choose to use ribavirin in long COVID patients, how can they monitor or mitigate potential mitochondrial effects?
There are several ways to keep an eye on things, starting with monitoring lactate levels, especially after exertion, can help identify energy metabolism issues. Another could be muscle function tests or even wearable sensors to track fatigue could provide the real-time data. Blood markers for oxidative stress could help detect early signs of mitochondrial damage. Another thing can be co-supplementation with mitochondrial support agents like coenzyme Q10 or carnitine or B vitamins could be considered, though this is still in the preliminary stages of research.
So, the goal would be to treat with caution and just not targeting the virus, but at the same time protecting the delicate balance of our cells.
Exactly. It's about treating the whole patient, not just focusing on the virus.
Saakshi, thank you so much for sharing your insights. This discussion has certainly added depth to our understanding of how ribavirin and its effects on mitochondria could play a more complex role in post-viral recovery than we initially thought.
It was my pleasure, Anushka. Mitochondria are like the canaries in a coal mine for cellular health. We ignore them at our peril.
And that's a powerful reminder. Next time on ribavirin reminiscence and lingering load in long COVID-19, we'll dive into the theories of microclot formation in long COVID and whether antiviral interventions could play a role in addressing endothelial dysfunction. Until then, I am Anushka, reminding you to look deeper than the data and always listen to the biology beneath the surface.